Hello students, this is Yashadhari. In this video, we know about how the scanline algorithm is used to fill the polygon. Before that, we know what is the drawback or a limitations of a seed filling algorithm. Why we have to move on to the scanline. Okay. So first is it is recursive implementation to fill the polygon with using a 4 connected and 8 connected, right? So for this it will consuming a memory, as well as each time you have to store the pixels and check the pixel is empty or it will not fill with the previous color and it is not matched with the boundary color, right? So it will take the time as well. So if any of the inside point or a pixel is already in a specified color, then recursive call terminates, means that the process will stop there and it will, the remaining part of the polygon is unpainted, or you can say it will fill with the color, right? This is one of the limitations of a seed fill algorithm. So seed fill is not suitable for a large polygon fields because they use a stack structures to store a neighboring pixel, so it consumes a large memory space as we discussed in this slide. Okay, so for this reason we move on to the scanline algorithm, right? So what is a scanline? As the name said, it is scanning the whole polygon by line. Okay. In this method, given polygon is filling with a specified color by scanning whole polygon line by line. Okay. So while scanning the polygon, it starts from a x min and y min to a x max y max. Means it will give a length and a height of the polygon. Okay. So x min it initialize where the actual starting the polygon, and x max is the end of the polygon. Y min and y max is the height of that polygon. Okay, it's means when a scan line it starts from the bottom of the image to the top of the image. Okay, here the pseudocode is there. So first we have to say y equals to y min to y max, and finding the intersection of a scan line y with a polygon edge. Then we sort the intersection points by x coordinates. For I equals to 0 to the number of intersection, step 2. Now you have to fill the pixel from a x of I to xi plus 1. What is a pseudocode? How it is actually processing? We'll see. Means first we have to find out the y min and y max, that is the lowest and highest point of the polygon. Then we have to scan a polygon with a line by line, that is between a y min to y max. So with the help of a figure we understood. In a scan line, the main step is we have to maintain the active edge table. Okay, this is all steps of to perform the scan line. Here we are giving the taking the one example of a polygon. No, in this we maintaining the active edge table. This is okay. Active edge table we maintaining the whatever the edges. First we have to initialize the edges of the given polygon. Here we am taking the A. Okay. So edges we have to mention, and then how the scan line are moving. In that manner we have to add the what we have to say to adding the edges. First we have to need to add the all the edges in the polygon. Here what are the edges? Edges means a vertex line. AB is there, BC, CD and DE and AE, right? These are the edges of a given polygon. Now how we have to sort this, means the intersection. Now what is the active edge? Means where the scan line are moving. Means here this first scan line is there. So what are the intersection point here? This is A and here it will intersect it. So what is the active edge table content now? In active edge we have to mention the AB, right? Next your D and E are the active edge, right? So line is passing through these lines, right? So coordinates we have to mention here. Starting we can take the scale 2 4. Okay, how to take the scale? This is the, okay, 8 10 and 12. Okay, so this is the end of this x coordinates. Like that we have to mention the y coordinates as well. Okay, here 0 0 of a y mean x mean, here 2 4. We have to understand this. We scale, just we maintaining a scale, we give assigning the scale of this one. Okay, it's a 10 12 and 14. Two's difference we are taking. Okay, so like this. Now what is the x and y coordinates? How we have to take the in a ascending order means x coordinate ascending order. First A and B. A is a 2 comma 2 2 comma 2. Next we have to take B, that is a 2 comma 2 comma it's a 10 or 11, a scale. You have to consider that scale. Now next is a D and E. Is a, you having a scale of x is 12 and y is 2. Okay, next is your D, that is a 12 comma 14. 12 comma 14 is your these coordinate of x and y. So like this we have to mention the, okay, this is a filling. Now in this, consider this line, how the edges will be intersections we will counting that. This is active edge is AB, right? AB is active. Next this vertex here, this line is encountered with the this edge, right? So for that we have to take the BC as a one edge, and then you have to take a CD. Okay, then we have to take a D and E as well. Means if your line is scan line is encountered with the vertex, that vertex you have to count 2 times. So now the coordinates we have to assign in a ascending order as a similar like this. Okay, AB is in, now line is in a 10, sorry 2 comma 10, that is a x. 2 comma 10 is a for a B is a 2 comma 2 comma 11. Okay, like this you have to arrange the coordinates in according to the ascending order of x coordinates, right? So this is a, what is the advantage of this? It is efficient for filling a large polygon. Why we saying that? Means once we getting the intersection point, then we have to fill the whole the line pixels at once. Okay, for that it gives a efficient filling. Then it works well with the convex and concave polygon, because we are intersecting with the vertex. We have to just counter twice, 2 times for the vertex, and it is reducing the redundant filling of a pixel. As it is in a, you see in the seed fill, it will not redundant anything. Okay, because it will scan the line by intersecting a line, it will fill at a once of the whole the pixels. Okay, what is the disadvantages? It's a complex for a polygon with the intersections. Self intersection means if the polygon is given as a like this, means like if it is this layer polygon, you want to fill this one, means the here the vertices are there. If the more than, it will take a time consuming because we are counting twice for each, means here we have to count more than say 7, means here how many vertex we are passing, the time that will time consuming. Okay, and it will requires maintaining edge tables and active edge list. For this purpose, it is these are the disadvantages of a scanline algorithm. Okay.